Hello and welcome to another video from Ellensburg Amplifier Repair and Service. Today we have a Hifonics, well, let's back this up. We have a Maxonics amplifier, the Hifonics Brutus BXX 3000.1D amplifier that came in that had 3 blown 064s. Whoa, this is like a big springboard. Oh, this is a pretty flimsy board. Let me get some underneath that board here so we don't stress any traces. So, that's better. Much better. All right, where was I? Oh, the power supply. So, this came in with 3 burnt power supply transistors. Otherwise, it's an overall standard amplifier. Using, let me see if I got the output card on view here for you. All right, so typical power supply, some IRFP 064Ns being driven probably by 669s. Probably. It could be driven by, or it could be 600s. Actually, those are the BD style. I wonder if someone changed them. Oh, someone? Oh no, those are factory. So this uses the BD139 and BD140. Ah, interesting, Maxonics. That's interesting. I have never seen the actual board come with the BD series transistors, and I don't know if it's been worked on before. It could have been worked on before. So, but I don't see anything on this board that tells me it's been worked on before, so those might be original. Typical power supply. Output section, we have 2 IRS 21844 ICs that are driving, believe it or not, 31N20 transistors, which kind of caught me by surprise also. Yeah, they're all N-channel, of course, okay. I don't think I've ever seen them use the IRS IC to drive the 31N20s. So this is a very different amplifier. Strappable, a strappable 3K from Maxonics. Very interesting. However, let's see here. What I did is, when I first see something like this where I have 3 transistors blown on a power supply, gate resistors aren't burnt open, no other transistors are burnt, drivers are okay, there's no burning around the drivers, so something has happened to this board that tells me that it wasn't an overload of the output section. There's no shorts out here so far that I'm aware of. There's no over voltage situation. Usually you'll see that in the filter capacitors depending on the size. So these are 25 volt filter capacitors, so you may not see anything happen there. But what you have is you have 3 transistors here, 3 transistors here. These 3 drive this half of the transformer. These 3 drive this half of the transformer. So when I saw that these 3 transistors were shorted, but these weren't, that really clued me in that there's something else going on with this board that potentially could make this not economical to repair. My first thought, shorted transformer. I'm going to turn my meter on here, my digital multimeter, on to resistance mode. Of course, 99% of the time I use resistance. I'm not like, in my opinion, I'm not like the other repair people out there. Resistance tells me a lot about a circuit. Just a tremendous amount of information based on the resistance. And of course, you know, someone that's used to using diode mode would be able to use that same information to diagnose the problem. I recognize differences in circuits easier by using resistance than I do a full voltage drop. So what I wanted to really point out was the reading I'm getting across these primary and the secondary of this transformer. And remember, I'm talking the primary and the secondary. 6.2 ohms. Well, that is very, very unfortunate. The other transformer, now remember that's primary, secondary. So when you have switching starting and you have a primary, secondary short, whatever's on your primary is going to try to go out your secondary. So 12 volts in, at 10 ohm short, you're going to have 12 volts already going out on your secondary, which you don't want. They're supposed to be isolated. The other transformer, 6.4 ohms. This one is shorted primary to secondary. Remember, we only lost 3 transistors. So I'm like, all right. So I started digging around. I'm like, oh, well, we have a little bit of arcing that has happened over here at this bus bar. I kind of just see the little shiny copper right there where it took off the solder mask. Okay, all right. I'm like, all right, we got to get this board out and see what's going on. And then as I'm disassembling, I come across this screw, and I'm like, oh man, this screw has even been hot. So I knew something was not right. So I disassembled the board, pulled the board out. This is what I found on the inside of the heatsink. Yeah, okay, all right. Well, we have a lot of burn marks there. Scorch marks, transistor guts. And then I flipped the board over. Oh my. Well, guys, this is what we have. This is what is found. I don't know what else to say about this, but now I know what this is. This is liquid damage. Something spilt inside the amplifier and made its way across the bottom of the board. And this is what is left. You should see what coffee did to an amp. It's pretty cool. Coffee? Oh yeah, this is bad. This is, ugh. Oh yeah, I'm recording this mess. Yeah. But yeah, so there's a liquid that got spilt on the outside here, made its way through the board, started finding its way right across the primary traces, and as you can see, this was actually running at some point with this liquid in the amplifier because there was current at the output terminals that has eaten away at the liquid here. So it was actually running when it was wet. But this liquid has come down and it has just destroyed all the traces. All the copper. These traces are, oh, that actually might be solder mask. Traces might be okay, but unfortunately, there's the burnt PCB. So there's my tweezers sticking out of the board. So, I'm probably going to have to declare this one not economical to repair. I can repair it. It's going to be quite expensive to repair. So if this is a collector's item that someone has for a collection, they may spend the money to rebuild it, or they may not. So Before I put any more time into this board, I'm going to contact the owner and let them know that there is a 2x2 hole here in the board that probably needs to be replaced at about the same cost of what it would be to buy one of these. But I just figured I'd show you guys what I found on this fantastic, spectacular 3000 watt amplifier. So I do thank you guys for watching. As usual, stay safe out there. Oh, I just made a mess all over my table. Stay safe out there. Keep your fingers safe. Keep your fingers out of the rails, even though on something like this, you're not going to have any rail voltage. But if this was charged, be careful. They do hold quite a bit of current, or quite a bit of energy. So I do thank you guys for watching. Stay safe. Keep your fingers safe. Keep them out of the rails. Catch you on the next one.